Hello, my friends. Hey, thanks for working so hard while I'm not there. I know these videos aren't great, and learning this way is not optimal, but this is better than nothing, and we got to keep moving. We're almost done the school year, and I can't just take days off, and nor can you. And I've kind of paced this and done this so that it's very doable by yourself and with the people around you. And I think as long as you're listening and working with me, I think we can keep pace with this. And again, I apologize. I'll be out Wednesday as well, but then I should be back, and then you'll get sick of me once again. So this one's called Connecting to the Coordinate Grid. And the reason I say that is because we're now starting to move from this idea of just opposite, adjacent, hypotenuse, that kind of stuff, to X, Y, and R. So I want to talk to you a bit about that. In this situation here, let me just show you this is the old trig right here where we have, we label our opposite, our adjacent, our hypotenuse, and everything is kind of in a world that is just on a blank piece of paper. Where we end up going is to a world like this, where now we're going to think of kind of that adjacent side as being the X value, the opposite side being the Y value, and R being the radius or the hypotenuse. Now, when we look at it in that aspect, we find out that we can make some new formulas, and these formulas are important to us. They're not really new. It's still opposite over hypotenuse, which is the Y over the R. Cosine is adjacent over hypotenuse, which is X over R. And tangent is opposite over adjacent, which is Y over X. So that's the first thing I need you to be thinking about as we move forward, that X values connect with adjacent, Y values connect with opposites. And these new formulas, we need to learn them. The next thing that I want you to surprise you with is that in geometry we taught you three ratios: sine, cosine, and tangent. We said, hey, these are the trig ratios, and you use them and so on. Well, the truth is there are three more, and that might mess with your mind a little bit. They are called cosecant, and that's written CSC, secant, which is written SEC, and cotangent, which is COT. Now, where do these come from, and why do they all of a sudden appear? Well, what they are is actually what you would expect actually about a ratio, is that in the three that we did like opposite to hypotenuse. Well, a ratio can be written in two ways. You could flip it upside down and go hypotenuse to opposite. And that's what exactly these three new ones are. So they're really not new. They're just the inverses of what you already know. So, the reciprocals of what you know. So Y over R, this is R over Y. This is Y over X, this is X over Y. Now I do want you to notice something about sine's partner, its reciprocal partner, is cosecant. That's tricky for some to think about. You want to connect sine with secant, S with S, but it's actually the S connects with the C. Sine connects to cosecant. You'll notice the same rule, the S and the C connect. The cosine connects to the secant. Those are the partners in reciprocation. And then everybody knows that tangent and cotangent are the partners there. So even though they're new to you, they're really just reciprocals. So today is just still some basics. That's not a lot of new information, but it's worth maybe just pausing and making sure that things are clear to you. So let's just show you an example of one of the styles of problems. Now this one isn't exactly the same as the one on your worksheet, but here they're going to provide us a point. Now, what I want you to recognize is the 12 is the X value. Ding, 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 that's adjacent. And the 9 is the Y value, which is our opposite value. Now what's missing when I give a coordinate, of course, is always the hypotenuse, or our radius. So we can do a little solving here. Let me see if we can do that. Let's do a little solving here. So again, if this is a 12 and this is a 9 here, the first thing you'll want to do is obtain the R value. And in my life, I know some of these Pythagorean triples, so I'm not going to do all of the work here, but you will want to do the work. Most of these are triples, which means they should come out to be nice answers for you. And I'm aware that 3 squared, or 9 squared plus 12 squared equals 15 squared. So I'm going to find out that this value is a 15. Now once you've obtained that value, you can begin to do the answering of the question. So really there's no real hard, tricky item here. You can write down what the sine of that angle is. Now the sine of that angle is simply the y value over its r value. Simultaneously, if you can solve that one, you can also solve cosecant, because cosecant is the reciprocal. So that would be the h over the y. Now, I won't do all of the ones. I could do cosine, I could do tangent now. All of those are very doable now. And I can just fill them in. So it should be quite simple to doing that. I don't think it asks you to find the angle. Let me just take a quick look. Actually, it mentions finding the angle. So let's do the finding the angle. That's a little bit more interesting, I think, for me. Now, we are in quadrant 1, so what I'm going to do is I'm going to use this sine value. So I'm going to do the inverse of sine at 9/15. And this will give me my angle. I'm in quadrant 1, so the angle it comes out to be will be my value. So let me just grab my phone, or not my phone, but my calculator here. Second sine, 9 divided by 15. And I get 36.87. Now, if I was in a different quadrant, that would be the reference angle, not the actual angle that I'm looking at. And you'd have to maybe do a little adding or subtracting to get the actual value. But this is an angle definitely in quadrant 1, because quadrant 1 is between 0 and 90 degrees. And so that is my answer. This would be the angle I'm looking at. Let's see what else we got in here. Oh yeah, let's look at the back side. Let me do one of these questions. It's very similar style. And the clues that they give you are a little bit different. Let me see here. You know what? I made a little error on this one. This should be, I was quickly making a new problem for us. This should be a 3 here. Yeah, it should be. Let me do something quick here. Let me bring this up over here in a different format, and then I'll be able to show you here what this is about. All right, let's paste that in there. Okay. All right, so I want to just do a quick fix on this. I'm just going to hard mark this in as a 3 here. Sorry. So what this is they're going to give you sometimes 1 ratio, maybe 2 ratios, and from that you're going to gather what diagram you're looking for. It says that we're in quadrant 1, which my picture shows me. Now cosine is 2 over the square root of 13. Now cosine is x, so the 2 would be here. And the square root of 13 is my r, or my hypotenuse. So that gave me clues to those two sides. And then over here, sine would be the opposite, or y, which is 3 over the square root of 13. And so now I have my sides, and I can now do cosecant, tangent. If I wanted to do tangent of that reference angle, of that angle I'm looking at down here, it would be a 3, because that's my y, over a 2, that's my x. There they are right there. I could do cotangent. I could do a number of these, because cotangent will be a 2 over the 3. Let me give you a couple other quick clues. If you know cosine, which they gave you, then you know secant. And if they give you sine, then you know cosecant. So some of those questions will come quite quickly. They don't always give you 2 ratios like this, and if they don't, if they just give you 1, then you might have to use the Pythagorean theorem to find the third side like we've done. So I don't think anything really too crazy new here for you. Basically, you're just going to use the fact that you've now learned that there are 6 ratios in total, that 3 of them are reciprocals of the other, and that the values, when you're given a point, give you the x and the y coordinate, and you need to use those to get the radius or the hypotenuse value. Then you can find sine, cosine, and tangent all you want. All right, this shouldn't be too difficult. We need you to complete this for tomorrow. Thanks, you guys.